And with this, I would like to open the floor to the two participants who are joining us today, who were part of ESoC last year. It is Roshni Biswas and Timo Kelder. And I now hand over first to Roshni, who will let you know how her experience was in participating ESoC. And I warmly welcome Roshni, and the floor is yours.
Hello, my name is Roshni, and I am one of the past participants of ESoC from 2020. And I'm here to share my experience during the ESoC program, what I worked on, and why I would highly recommend you to also apply to ESoC 2021. So I have a couple of slides that I will share. I hope you all can see my screen. All right. So during ESoC 2020, I worked on a project called DeepJeff, which focuses on better predictions of wildfire danger and wildfire spread dynamics. We were a team of 3 having a background of engineering, and we have varied skills and prior experience in scientific software development, machine learning and AI, all proficient in coding in Python, having developed models in frameworks like PyTorch or TensorFlow in the past. And we also had a bit of experience handling these large geospatial data sets. Some of them are high resolution satellite observed imagery and require knowledge of, the Earth observation nuances. But all of that helped, and we figured that the 3 of us were quite leveraging our past skills and able to handle a project like this. We found out about ESoC on Twitter, and it happens that the ECMWF and ESoC community is very active on social media and are constantly sharing the workshops at ECMWF, or these kind of AMAs or programs like ESoC. So that was very helpful, and we in particular found ESoC very exciting because firstly, it's open source, and contributing to open source is always awesome. We also got the opportunity to contribute to real world impactful problems, and all of the challenges at ESoC are so impactful, and you basically contribute to the impactful projects in climate change, in improvements in Earth observation, and benefiting from the mentorship from the ESoC scientists who are also brilliant and helpful in terms of guiding us during the project, and also access to these high performance computing solutions like the European Weather Cloud and Wakio really enabled us to perform well during the project, because in machine learning and deep learning, these computing resources are really essential. Coming to the application proposal, I think we spent quite a bit of time just understanding the problem itself. While there is a challenge page on GitHub, we had to perform like a very extensive literature review to understand what kind of solutions are already in place or at ECMWF, which we can borrow ideas from and then improve. So we first understood the problem, asked questions on the issues page, and once we had a good understanding, we formed like a timeline of how those 4 months of the development period would go, and how much of the goals that we have would be feasible within the ESoC timeline. So we drafted this plan with very quantifiable goals and deliverables, and made a proposal with all the references that we had used to form it. And the experience itself was fantastic. So once we got selected, we started talking to our mentors. We got added to a Slack. The entire team was globally distributed. Like all 3 of us team members were on 3 different continents, and so were the mentors. So it was a challenge in just setting up communication, setting up a common place where we would host the data. But with ESoC staff, we were able to set those up very quickly in the first couple of weeks and move on to actually working with the data sets. We also met with the mentors quite frequently. So in the beginning, more frequently, more like once in 2 weeks. But then towards the end, when we got a better hang of the project, we met like once a month. And we would constantly be in communication over Slack and make code releases on GitHub. So whenever, say, the mentor spotted an issue with our code or had feedback, they would be able to communicate immediately, and we would correct those problems and make another code release. So yeah, the experience itself was great, and I personally learned a lot. And like, since this happened during the pandemic, I would say it was probably one of the best things that happened to me during the pandemic. I got to learn so much about, like, I got introduced to this field, and now I know what are the ways forward in this field, and also was able to contribute to a real world problem. So in particular, like, if you want to know more about DeepJeff, you can visit the GitHub repository. It's on the ESOC page at Wildfire Forecasting. And the premise of our project was that ECMWF currently has existing systems to measure wildfire danger and predict it. But these systems were developed a couple of decades ago, in the 90s, and written in Fortran, and they don't necessarily leverage the latest and greatest developments in, say, machine learning, advancements in AI, in geographical information systems. So that's where we came in, and we decided that first, what we're going to do is we're going to figure out what these indices are. So we specified, the proposal specified the fire weather index and fire radiative power. These are the two indices that we are going to decide to forecast better. And then we developed a timeline and a set of goals that first we're going to reproduce the existing system, and then we're going to improve it. So these were the list of goals. We also had we also had a timeline. So the first couple of months was just procuring the data, cleaning it up, wrangling it, making a prototype model. And then towards August or September, we decided to, say, improve the accuracies, refactor the code base, allow improvements in extensions of features. And then finally, last month was just documentation, preparing reports, presentations, and wrapping up the project essentially. Um, a quick look at our results. So the model that we developed was a neural network model in the style of a UNet. We got accuracies in the range of 70 to 90% for 10 days of prediction, which was in line with what we had set out to develop. A pictorial demonstration of these predictions are here. This was one of our case studies, which we performed on the wildfire season of Australia in 2019. So this kind of gives a visual demonstration of the FWI index when projected on a map. Also, our first goal was to reproduce the existing predictions. So we were able to benchmark with existing solutions. And the line graph here represents the existing solution, and the bars are what we developed. So we were also able to perform as well, if not better than the existing solution. So that was also very exciting. The key takeaways were that we realized that the cleaning and pre-processing is, at least in this geospatial field, is very important, and probably even more difficult than the actual machine learning development. It takes a lot of time to make sure that all the input features are in the right resolution, they have the right feature names, and they're all compatible with the system. The nuances in metrics are very important. One anecdote that I can share is, first, when we created the prototype model, we were getting like 95% accuracy, 90% accuracy. We were all very happy. But then when we spoke to our mentors, they said that maybe you should have a more closer look at the metrics and see if you split up the FWI into various different bins and look at the higher values and the lower values and which one is performing better. You'll see that there are more nuances that you should also pay attention to rather than just the top level numbers. So that was quite useful guidance. We also realized that writing good quality code is more important than getting quick results, because later on, when we needed to, say, add a new feature, then if the code is not good, or if it was developed by somebody else and not documented, then the other person is not able to quickly add the feature. So it's very important that documentation is in place. And we had fun. We had a very good time throughout the course of the 4 months of the coding phase. And I highly recommend the ESoC program. We got to learn a lot, worked with so many brilliant scientists and engineers at ECMWF. We got a taste of open source, we made impactful contributions, and I sharpened my skills in both software engineering and just managing the project in general with all these different team members in different places. So I highly recommend the program, and I hope that I wish you good luck in creating your application, and I hope you have a good time developing good innovative software with ESoC.
Thank you so much, Roshni. And it was really a pleasure to have you in the ESoC last year.
Thank